Hi friends, this is my third lecture and today we will study some basics about transmission line. So first we see what is transmission line. So transmission line basically is a link or power carrier between two buses. Now what is bus? In power system, buses are the conductors or parts of substation where transmission lines meet. Let's understand it more clearly. Do you remember the chapter graph theory? Graph theory was chapter in subject electrical networks. In graph theory, we used to represent an electrical network using a graph. Graph of electrical network has two main components. One is branch and another is nodes. Nodes are the point where more than one branches meet. Similarly, we can compare power system with a graph where transmission lines are equivalent to branches and nodes are equivalent to buses. These transmission lines are made up of aluminium. We know that copper is better conductor than aluminium, but why transmission lines are made up of aluminium? So the reason for this is, first reason is aluminium is lightweight, so it imposes less burden on tower. Second reason is aluminium is cheaper than copper. And third and weird reason is aluminium has more resistivity. But having more resistivity is negative or bad for a conductor. Then why we use aluminium instead of its high resistivity? How it is advantageous? I will tell you all this in my upcoming lecture. Fourth reason for using aluminium is corona is less in aluminium conductor. Now we see why corona is less in aluminium. Corona means breakdown or ionization of surrounding air of conductor. This happens when field of conductor is more than breakdown strength of air. We know that electric field due to a conductor is given by E is equals to rho L by 2 pi epsilon R, where rho L is the line charge density and R is the radius of conductor. Now take two wires. One is made up of aluminium and another is made up of copper. Both wires have same length L. And resistivity of wire of copper is rho Cu and resistivity of aluminium wire is rho Al. Now the resistance of these two wires is same. So we can write resistance of copper is equals to resistance of aluminium and resistance of copper is rho Cu into L by ACu and resistance of aluminium is rho Al by L, rho L into L divided by AAL. Means resistivity of aluminium into length of aluminium divided by area of aluminium. So here you can see length of both the copper and aluminium conductor is same while resistivity and area is different. Now equate both equations because we assumed that resistance of both copper and aluminium is same. So on equating we get rho Al means resistivity of aluminium divided by resistivity of copper is equals to area of aluminium divided by area of copper. And we know that resistivity of aluminium is greater than resistivity of copper. So we get resistivity of aluminium greater than resistivity of copper. It gives area of aluminium greater than area of copper. So we can say that for same resistance, area of aluminium will be greater than area of copper. So more cross-section area means larger radius because area is directly proportional to the radius. So finally we can say that radius of aluminium is greater than radius of copper for a conductor having same resistance. So radius of aluminium is more than that of copper for same resistance. Now we know that electrical field E is inversely proportional to the radius. So electric field due to aluminium will be less than that of copper because radius of aluminium is greater than that of copper. That's why corona is less in aluminium than in copper. Now we will discuss the desirable properties of transmission line or desirable characteristic of transmission line. First desirable characteristic of transmission line is low power factor and high efficiency. Second is voltage drop should be as low as possible to ensure the availability of rated voltage at consumer end. So these are the two desirable properties of transmission line. Now we will discuss the ratings of transmission line. First is voltage rating. It is RMS line to line voltage of transmission line. RMS line to line voltage is directly proportional to the insulation requirement. Here insulation means disc insulator. Okay. Now second rating is current rating. Current rating is RMS line current carried by transmission line. Current rating is directly proportional to the area of cross section of the conductor. And third rating is MVA rating. MVA is equals to root 3 VLIL. So these are the three ratings of transmission line, and this is all about the basics of transmission line. I hope you like the video. Thank you. Jai Shri Ram.